These are notes for section 2.5 and 2.6. That's compound inequalities and absolute value inequalities. We'll take 2.5 first. Compound inequalities. This word compound simply means that we have two inequality signs, two signs for one problem. Now, we discussed in an earlier video how to solve simple inequalities with one inequality sign and the graphs to go with it. Well, these are notes to solve a problem with two inequality signs. For example, number one, you can see an inequality sign here and an inequality sign here. That is a compound inequality. The nice thing about these is they solve exactly the same way. Distribute, combine like terms, pick on the little guy, get the variable by itself. A lot of what we borrowed in chapter 1, but now we just have to do it 2 times over. So the first thing we want to do is, again, distribute if you have a set of parentheses. So that would leave me with negative 10 less than, after I distribute the 2, which means I am multiplying. After I distribute, I go through and combine like terms. Again, distribute, combine like terms, pick on the little guy, get the variable by itself. These are notes that have been discussed on almost every video. Now, once we end up, after distribute, combine like terms, we have two inequality signs. So whatever I do here in the middle, I'm going to have to do on both sides. So I add 8 to get rid of that minus 8. And whatever I do here in the middle, I have to do to the other side as well. So I add 8 over there. That would leave me with just x. And now 3 plus 8 would give me 11. And negative 10 plus 8 would give me negative 2. Sorry about my sign there. That is not equal to. It should just be less than. There we go. And so my answer is negative 2 less than x less than or equal to 11. If you were to look at a graph of this, again, borrowing from 2.1 through 2.4 in a previous video, we know that we have a closed circle at 11 and an open circle at negative 2. If I just look at one of the statements here, if I just take a look at the portion x is less than or equal to 11, well, less than 11, I would shade to the left. If you hit another circle, that's like a stop sign. You cannot shade over that circle. And that's my answer. These are the solutions. These are the numbers that make this inequality true. Everything between negative 2 and 11. Now, number 2, you'll see what we have this word or. That does not mean solve this one or that one. That means I need to solve them both. I have to solve both of these. It is a compound inequality. And to solve them both, again, I do the steps from chapter 1 and early chapter 2. To get rid of a plus 7, I subtract. To get rid of a times 2, I divide. That's x is less than negative 6, or you could say negative 6 is greater than x. And on the second part of the compound inequality, to get rid of a plus 4, I subtract. And to get rid of a times negative 3, I divide by negative 3. And negative 18 divided by 3 is positive 6. So again, I have two inequality signs here, and I can graph this by making my number line and putting numbers on the number line. So here's 0, negative 6, positive 6, open circle here, open circle here. And again, to figure out which way to shade, I just look at one of the statements. Negative 6 is greater than x. Or you could say x is less than negative 6. Both of these statements say the same thing. I shade to the left or the outside on one of them. If you shade outside on one, you shade outside on the other. So your compound inequalities are either both going to shade in, like on number 1, or they're both going to shade out, like on number 2. And you can find this out by just looking at one of the inequality statements. For section 2.6, absolute value inequalities. They solve a lot like absolute value equations. Again, this was an earlier video, chapter 1, section 5 or 6. I can't remember the exact section number. But in order to solve, we first have to get the absolute value bars by themselves. So to get rid of a plus 8, I subtract 8. That's the absolute value of 2x greater than 10. Once the absolute value bars are by themselves, I can split it up into two problems. That's 2x greater than 10. If we remember from absolute value equations, I make the second one negative And here's the one catch that makes equations and inequalities different. You have to flip the second sign. When you set up your second inequality, you have to flip the second sign. The reason is if you don't, you're going to have some overlapping shaded areas and your solutions are going to have some wrong numbers. And then once you flip the second sign, we can divide by 2 to solve both of these. Oops, there we go. And we end up with x is greater than 5 and x is less than -5. Again, we have a compound inequality because there are 2 inequality statements. I look at one of them, x is greater than 5. From 5, I shade to the right. If you go outside on one, you go outside on the other. And on the last one, divide, on number 4, we have to get the absolute value bars by themselves. So I divide by -2. Again, another rule from 2.1 through 2.4 in the previous video, if you multiply or divide by a negative, you have to flip the inequality sign. So it was greater than, it is now less than. Once I have the absolute value bars by themselves, I can split this into 2 problems, one to the positive, one to the negative, and on our second inequality, you have to flip the sign. So on number 4, we flip the sign here twice. I do it the first time because I divided by a negative, that's a -2, and I did it here when I set up my second problem, so I end up with the correct solutions. And then from here, I can just solve both of them. I get 2 answers of 0 and -8, and if I put my graph over here to the side, 0, -8, close circle at both of them because it's equal to, again, that's covered in an earlier video. And I look at one of my statements. X is less than 0. From 0, I shade to the left. And if you shade inside on one, you shade inside on the other. Those are notes for 2526. Hopefully that was helpful.